All right, good people. Today is Tuesday, the 28th. It's the last day of the month. If we haven't done so, please make sure that your first and last name is on your packet. This week, the items that are due this week, we have our warm up, we have our homework, we have our test on Friday, and our iReady project is due on Friday as well. We've had 5 weeks to do 3 lessons, okay? The essential questions are as follows. What is a system of linear equations? What does it mean to solve a system of linear equations? And describe how to graph a system of linear equations. Today, we're going to go over the warm-up. Of course, we're going to write in our planner. I'm going to finish the foldable. And we're going to work on graphing systems in the calculator. I hope to be able to start writing. We're going to start solving word problems with systems. So I'm going to go over just one equation first and then do 2 equations or systems on tomorrow. So I hope to be able to start word problems. Okay. We're doing Tuesdays. We're doing Tuesday's homework. We're doing Tuesday's homework. No tutoring this week. And there will be a homework help video for today as well. This is not mandatory to write, but please write the homework down in the packet. Check off if you watched the video yesterday, please check it off. If you completed the homework yesterday, check it off. If you already completed iReady project, check that off also. Math 8, we're going to write our homework down. Please make sure you watch the help video. Make sure that you complete your homework. And don't forget about the iReady project. No tutoring today, okay? No tutoring this week. I'm going to pause for the calls to give us a chance to write. If you already finished the iReady project, you don't need to keep writing that. I'm just writing it for those that have not completed it. All right, anybody still writing? Okay, let's look at the warm-up, please. Let's look at the warm-up, please. No, we're doing it now. All right, so let's look at Monday. We're going to do this one together. It says, suppose the water level of the river is 34 feet. Okay, so automatically it's 34 feet. That's the starting, which makes that your B. 34 feet. Okay, if you need to go, let's line it up, please. If not, keep working. Pause. Okay. All right, so it says, suppose that the water level of the river is starting, is 34. That means it's starting at 34. That's your y-intercept because this is your starting amount. And that it's receding. That means it's declining. Receding means it's decreasing. Okay, it's draining, it's decreasing at a rate. That's the key word right there. A rate. That's your slope. M. Negative 0.5 or 0.5 per day. This is another key word that this is the rate or the slope. How do you know it's going to be a negative 0.5? Because it's saying receding. Receding means that it's decreasing. Okay? It says write an equation. We know it's going to be a linear equation because the rate is consistent. Okay, thank you. Because the rate is consistent. So the equation we're writing in slope intercept form is y equals mx plus b. The M is a negative 0.5. So we got y is equal to negative, we could say 0.5 or 5 tenths x plus the starting amount of 34. This is our equation. Okay? I'm going to read Tuesday. Seth's father is thinking of buying his son a 6-month movie pass for $40. Okay? $40. That's how much it's going to cost for 6 months. With this pass, the matinee is $1. So he's going to pay $40 automatically. That's the starting amount. He automatically is going to pay that $40. And every time he goes, he's going to pay $1. Matinee means a movie, a daytime movie. That means you're going before like 5 o'clock. It's like 12 noon or whatever. It's cheaper because it's encouraging people to go to the movies at an earlier time because most people like to go at night, right? So it's encouraging business all day by making it cheaper for daytime movies, okay? All right, that's what a matinee is going to the movies in the day. So M, during the day, it costs $1. So he automatically buys these tickets for $40. That way, every time he go to a matinee or go to the movies during the day, all he have to do is pay $1. That's what it's saying. All right. So the equation here for this first sentence, we write in slope-intercept form. It's going to be $1 every time you go to the movie, plus he already paid that $40. Okay, so that means he's going to go to the movies as much as possible to get his $40 worth. If he's smart, that's what he would do. If matinees normally cost $3.50 each, okay, so that means for the second, matinees automatically cost $3.50. Automatically costs, okay? The equation for this scenario would be y is equal to 350x. So we got two equations. The question is, see this comma? How many times must Seth attend in order for him to benefit to buy the pass? Okay, so we're going to type these equations in the calculator and then we're going to compare them to see when is it going to be cheaper for him to do this than this. Okay, let's go. Let's clear our calculator. 2 plus 7, 1, 2. Now we're going to type both equations into the calculator by pressing y equals. We got Seth's father pays $1 x, $1 for every matinee, but he automatically paid $40. Okay, that's the first equation. The second equation is 350x. Without the discount, it's $3.50 every time you go. Please make sure that you type both equations in. Make sure that you type them in. You got your calculators? Got your calculators? Come on, let's do it. Type it in, type it in. All right, so now let's view the table. Ooh, stomach. All right, so let's make sure we do this. So we got second graph. So now we're going to compare the two equations. This is the first equation, Seth's father. This is the second equation, what it automatically costs. All right, so see, if you don't go to the movie theater at all, for the first scenario, you already done paid the $40. For the second scenario, you paid nothing. So if you're not going to go to the movie theater, then it's no reason for Seth's father to pay that $40. That makes no sense. Keep going. One ticket it's still going to be cheaper to just pay the $350. At 2 trips to the movie theater, it's still cheaper to pay the $350 for every single time. At what point, how many times does he need to go to the movie theater for it to be cheaper for Seth's father to buy this than it is for him to just pay the $350? Let's keep going down. How many times would he have to go for it to be cheaper? Can anybody see it yet? Huh? 17. At 17, yes. So he would have to go to the movie theater 17 times for the discount to be worth it. If he goes 16 times, he breaks even. But if he goes 17, then it starts to be cheaper. So if he's going to the movie theaters a bunch of times within that 6-month period, then this would be cheaper. If not, he might as well just pay the $350. So the answer to the question is 17 times. He would have to go to the movie 17 times. Go at least for it to be cheaper. Okay. Pause for the calls, give you a chance to write. It's fine. Hello. All right. Me too. Okay, so let's look. Homework real quick. Guys. Good. All right. If the points are scattered everywhere, it's a no correlation. These are points are everywhere. Or ordered pairs everywhere. It's not going up. It's not going down. The points are just everywhere. If the points for the most part are going up, mostly going up, that's a positive relationship. If the points mostly are going down, it's a negative relationship. Mostly going down, that's negative. All right, so number 1, do you think that's positive, negative, or no correlation?
No correlation.
This one's no correlation. What about the second one?
Negative.
Negative. And what about the third?
Positive.
This is mostly positive. Good job. Okay, so let's look at the bottom. Here you're graphing the points. That's all you're doing here. Is that you're going to graph these points on this coordinate plane. That's what you're doing tonight, is graphing ordered pairs. Okay, so I'm going to graph the first one. The hours is X and the test scores is Y. So the hours slept, this is an ordered pair. 8, go along 8 here and go up to 83. This is 80. 83 is somewhere in the middle. 7 and 86. Go over 7 and go up to 86. This is 85. 86 is right above it. And you're just going to graph each of the ordered pairs. Then you're going to tell if this is positive, negative, or no correlation. Any questions about the homework? Okay, let's put this in our folder, please. I'm going to pause for the calls. Please make sure you take out your calculator, and then I'm going to give you this sheet here, okay? Oh, we need to finish the foldable. Please take out the foldable. I'm sorry.
Do we need to
take out the folder? We're going to write something in it. I'm going to pause to give you time to take the foldable out. All right, so you're going to take your pair of scissors, and we are going to cut. Go ahead, baby. Go ahead. We're going to lift the tab so that we're not cutting the whole thing. We're just going to cut on the dash line. Going to cut on the dash line. There you go. All right, at the top part, we're going to write system of equation. We got systems of equations. A system of equation is like it's more than one equation. More than one equation. In this course, we're only going to do 2 equations at a time. Okay? In other courses, in other future courses, you may do 3 and 4 equations at a time. Langston, you okay? Are you okay, baby? Okay. All right. So, like a bus system is more than one bus. A school system is more than one school. Body system is more than one body part. A system of linear equations or equations is more than one equation. Okay? When you're solving a system, that means you're finding where they cross. To solve, find where they cross. To solve, find where they cross. All right, if you graph them and they cross this point right here where they cross is the solution. The point in which the lines cross is the solution. So the ordered pair is going to be the solution. This has one solution because it crosses in one place. Zero solutions means they don't cross at all. That means the lines are parallel. They don't cross. That means there's no solution. Because the lines don't touch each other, they don't cross, there's no solution to this system. There is no solution to this system. If the lines happen to graph the same exact line, that means they share all the same points. I put a double arrow so you'll know that this is really 2 lines on top of each other. They share all the same points. That's why it's an infinite number of solutions. The lines share all the same points. I'm going to pause for the calls. So a system of equations is more than one equation, okay? A system means more than one. Like a bus system is more than one bus. A school system is more than one school. So a system of equations is more than one equation. In this course, we're only going to solve a system that has 2 equations, just 2 equations, okay? In other courses, you're going to do maybe 3 or 4. But in this course, we're just going to do 2. So if the 2 lines cross each other, that means they have one solution because they share one point. If the 2 lines never cross each other, that means they have no solution because they don't share any points. If the 2 lines are right on top of each other, that means they share all the same points. And since a line never ends, they have an infinite number of solutions. So you're either going to have 1 point as the answer, no solution, or infinitely many solutions when you're talking about straight lines. Any questions? Okay, let's open the first tab, please, to do the first example. We've already done an example that looks like this. We're just going to seal the deal. Okay, so we are going to graph these two equations. We're going to graph y is equal to 2 over 3x plus 8. And we're going to graph y is equal to a negative 2x. Okay, we're going to graph those two equations and find the solution. The first equation, to graph it, you have to identify the m and the b. What is the slope of the first equation? 2/3. You're right. This is rise over run. The number that's attached to the x is the slope. That's your m. The number that has no variable attached to it is your y-intercept. That's your b. So now we're going to graph that. We're going to find b on the y-axis. B on the y-axis, okay? 8 on the y-axis is up. 1, 2, 3, 4, 5, 6, 7. Positive 8 is right here. That's the first thing I do is graph my b on the y-axis. So whatever is b is, graph it on the y-axis. Now I'm going to use my slope, rise over run, to put points on the line. Positive 2 is my rise, so I go up 2. Positive 3 is my run, so I go to the right 3. So up 2 to the right 3. Up 1, 2 to the right. 1, 2, 3. Ran out of space, so I have to go in the opposite direction.
Down 2 to the left.
Very good. Down 1, 2. Good job, babe. To the left. 1, 2, 3. Down 1, 2. To the left. 1, 2, 3. Down 1, 2. To the left. 1, 2, 3. Down 1, 2. To the left. 1, 2, 3. This is where I draw my line, okay?
Miss Rice, can you put the other part again?
Yes, baby. Is that what you need?
Yeah.
Okay. All right, good people. Now we're going to graph the second equation. So we're going to label our m and our b. Our m, the number that's attached to the x, is negative 2. To write negative 2 as a fraction, we put a
1 underneath.
Very good. Top number is the rise. The bottom number is the run. There is no B present. This is sign language for B. I always do that. If you see me do that, that's B. Sometimes I just do sign language for no reason. All right. There is no y-intercept here. Y-intercept is 0. Okay. So now we're going to find 0 on the y-axis. 0 on the y-axis is right here at the origin. We're going to use our slope. Negative 2 over 1 to put points on the line.
Down 2 to the right.
You want me to zoom in, baby? Okay. So we're going to put our pencil here and we're going to go down 2 and to the right 1. Down 1, 2, right 1. Down 1, 2 to the right 1. 1, 2, right 1. 1, 2, right 1. 1, 2, right 1. Go until you run out of space. You want points in the opposite direction. We go up 1, 2, left 1. Up 1, 2, left 1. 1, 2, left 1, 1, 2, left 1, 1, 2, left 1, up 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 1, 2, left 1. This is my line. I made the point in which they crossed just a little darker so that you could see it. This is the solution because this is the one point that they share. What point is that? What is this ordered pair here? Go over to the left and then go up. What's this ordered pair? What is this ordered pair? Ooh. Very good, babe. Negative 1, 2, 3, and positive 1, 2, 3, 4, 5. Very good. 6. This is the solution. This is the one point that they share. All right, for one solution, what does it look like? The points cross. The lines cross. Sorry. The slopes are different. And really, it doesn't matter if the y-intercepts are the same. It doesn't matter if they are the same. They can be the same and still cross or not be the same. It doesn't matter. But definitely the slopes have to be different. If the slopes are the same, they would never cross each other. The slopes must be different. Pause for the cause. All right. 0. That means these lines are never going to cross each other. Therefore, the lines would be parallel. So let's graph these two equations. Let's graph y is equal to 3x minus 5, and then y is equal to 3x plus 1. In order to graph the lines, you have to identify what your M and your B is. What's the M for the first equation here?
3.
3. You write 3 as a fraction how?
1, put 1 underneath.
Very good. This is my rise. This is my run. What's the y-intercept of the first equation? What's the y-intercept of the first equation? Negative 5. Good job, babe. So we're going to graph this. We're going to find negative 5 on the y-axis, and we're going to use the slope, rise over run, to put points on the line. Positive 3 is up 3. Positive 1 is to the right 1. So let's find negative 5 on the y-axis first. This is the y-axis. Negative 5, 1, 2, 3, 4, 5. This is negative 5 on the y. Sorry, y'all. Now we're going to use rise over run to put points on the line. Your rise is positive 3, so we're going to go up 3. Your run is positive 1, so we're going to go to the right 1. Up 3 and to the right 1. So we leave here and go up 1, 2, 3 to the right 1. Up 1, 2, 3, right 1. Up 1, 2, 3 to the right 1. Up 1, 2, 3, right 1. Up 1, 2, 3, right 1. Opposite direction. We go down 3, left 1. down 3, left 1, 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 down 1, 2, 3, to the left 1. All right. Let's do the next one. The slope is 3 here. The y-intercept is 1. So this time we're going to graph. Start on the y-intercept, graph the y-intercept at 1, go up 3 to the right 1. Same slope. Start at 1, positive 1 is here. The slope is up 3 to the right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, to the right 1. They're not going to touch each other because it's the same rise over run. Opposite direction. Down, 1, 2, 3, left 1. Left 1. 1, 2, 3, to the left 1. And they're not going to touch because they have the same slope. What is the solution? There's no solution here because they don't share any points. What does it look like? Lines do not cross. They're parallel. Parallel lines have no solution. The slopes have to be the same. And the y-intercepts are different. If they were not different, it'd be the same line. So the y-intercepts have to be different. Pause for the cause. Infinitely many. We're going to graph y is equal to negative 2 over 3x plus 4. And then y is equal to, bless you, babe, negative 4 over 6x plus 4. We identify m and b. M is negative 2 over 3. Thank you. Bye, babe. The b is 4. M here is equal to negative 4 over 6. B is also 4. We're going to find 4 on the y-axis. 1, 2, 3. You need me to go back? Okay. 4. I'll go back. You're going to go down 2 and to the right 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Opposite direction. Up 2, left 3. Up 2, left 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1. 2, 3. I'm gonna go back. You said you wanted to go back and see this, babe? Okay. Let me pause. All right. The last, start at 4, down 4, right 6. Here's 4, down 1, 2, 3, 4. To the right, 1, 2, 3, 4, 5, 6. Okay. And what you notice is that it's gonna be the exact same line. So what do they look like? Lines are the same. Slopes, same. Y-intercept, same. If we reduce this fraction, it would be -2/3. Please make sure you put your calculators back, please. We're going to paste this in our notebook tomorrow on page 10. This is going to be pasted on page 10. Pick up your cell phones, please.